Hey there, science fans! Today, we're diving into the fascinating world of logarithms. Now, I know what you might be thinking. Logs? Like the ones we burn in a fireplace? Well, hold on to your hats because we're talking about a different kind of log, the mathematical kind. In the simplest terms, a logarithm answers the question, what exponent do I need to raise a base to in order to get a certain number? For example, the logarithm of 100 with base 10 is 2. Why? Because 10 raised to the power of 2 equals 100. 10 squared equals 100. See? It's all about relationships. Logarithms might seem a bit abstract at first, but trust me, they're incredibly useful tools for solving a wide range of problems. And the best part? They come with a handy set of rules that make working with them a breeze. Let's unlock the secrets of log rules together. So, why should we even care about these so-called log rules? Well, imagine trying to chop down a giant tree with a tiny pocket knife. It would be quite a challenge, right? Now, imagine having a powerful chainsaw instead. That's precisely what log rules do for us in the realm of mathematics. Log rules are like mathematical shortcuts, allowing us to simplify complex expressions, solve tricky equations, and navigate the world of exponents with ease. They provide us with a set of elegant formulas that transform complicated logarithmic expressions into manageable pieces. These rules aren't just for mathematicians, though. They have real-world applications in fields like science, engineering, finance, and even music. Understanding log rules empowers us to tackle a wide range of problems that involve exponential relationships. Let's kick things off with the product rule, one of the most fundamental log rules. This rule tells us that the logarithm of a product is equal to the sum of the logarithms of the individual factors. Sounds complicated? Don't worry, it's simpler than it sounds. Here's the formula: log base b of m times n equals log base b of m plus log base b of n. This means that if we have the logarithm of a product, we can break it down into the sum of the logarithms of each factor. For example, let's say we want to find the logarithm of 1000, which is 10 times 10 times 10, with base 10. Using the product rule, we can write log base 10 of 1000 equals log base 10 of 10 times 10 times 10 equals log base 10 of 10 plus log base 10 of 10 plus log base 10 of 10 equals 1 plus 1 plus 1 equals 3. See? The product rule makes multiplication a walk in the park. Now, let's delve a bit deeper. The product rule is not just a neat trick. It's a powerful tool that simplifies complex calculations. Imagine you have to multiply large numbers, like 123 and 456. Calculating their product directly can be cumbersome. But with the product rule, you can break it down into smaller, more manageable parts. By converting multiplication into addition, you can simplify the process and reduce the chances of errors. This is especially useful in fields like engineering, computer science, and finance, where precision and efficiency are crucial. Logarithms are used to measure sound intensity, earthquake magnitudes, and even in algorithms for data analysis. Understanding the product rule can give you a significant advantage in these areas. So, the next time you encounter a complex multiplication problem, remember the product rule. It turns multiplication into addition, making your calculations simpler and more efficient. With practice, you'll find that this rule becomes second nature, and you'll be able to tackle even the most challenging problems with ease. Keep practicing, and soon, you'll see just how powerful and versatile logarithms can be in simplifying your mathematical journey. Happy calculating! Section 4. Quotient Rule, from division to subtraction. In this section, we will delve into the fascinating world of logarithms and how they simplify complex division problems into straightforward subtraction. Next up, we have the quotient rule, which is like the product rule's close cousin. While the product rule deals with multiplication within logarithms, the quotient rule handles division. This rule is incredibly useful in various mathematical and real-world applications. This rule deals with division within logarithms and tells us that the logarithm of a quotient is equal to the difference between the logarithm of the numerator and the logarithm of the denominator. This means that instead of performing a division, we can simply subtract two logarithms, making our calculations much easier. Here's how it looks mathematically. Log base b of m divided by n equals log base b of m minus log base b of n. This formula is a powerful tool in simplifying logarithmic expressions and solving complex problems efficiently. In essence, if we have the logarithm of a fraction, we can express it as the difference between the logarithm of the top number, or numerator, and the logarithm of the bottom number, or denominator. This transformation is not just a mathematical trick, it has practical implications in fields like engineering, computer science, and even finance. Let's illustrate this with an example. Examples are a great way to see the quotient rule in action and understand its practical utility. Suppose we want to find the logarithm of 100, which is 1000 divided by 10, with base 10. This might seem like a daunting task at first, but with the quotient rule, it becomes quite manageable. Applying the quotient rule, we get log base 10 of 100 equals log base 10 of 1000 divided by 10, which equals log base 10 of 1000 minus log base 10 of 10, which is 3 minus 1 equaling 2. This step-by-step breakdown shows how the quotient rule simplifies the process. The quotient rule turns division into a simple subtraction problem. This not only makes calculations quicker, but also reduces the chances of errors. Understanding and applying the quotient rule can significantly enhance your problem-solving skills in mathematics and beyond. So, the next time you encounter a division problem within a logarithm, remember the quotient rule. It's a handy tool that transforms complex division into easy subtraction, making your mathematical journey smoother and more enjoyable. Keep practicing, and soon, the quotient rule will become second nature to you. Happy calculating. Section 5. Power Rule, bringing exponents down to earth. Today, we are going to demystify a concept that often seems intimidating, but is actually quite straightforward once you get the hang of it. Now, let's talk about the power rule, a rule that helps us deal with exponents within logarithms. This rule is a powerful tool in mathematics, especially when dealing with large numbers or complex equations. This rule states that the logarithm of a number raised to a power is equal to the exponent multiplied by the logarithm of the base. In simpler terms, it allows us to bring the exponent down in front of the logarithm, making the equation easier to handle. Mathematically, log base b of m raised to the n equals n times log base b of m. This might look a bit complicated at first glance, but let's break it down step by step. This means we can bring down the exponent in front of the logarithm and multiply it. Pretty neat, right? This simplification is particularly useful in various fields such as engineering, computer science, and even finance. For instance, let's say we want to find the logarithm of 10,000, which is 10 raised to the fourth power, with base 10. This might seem like a daunting task, but with the power rule, it becomes much simpler. Using the power rule, we can write log base 10 of 10,000 equals log base 10 of 10 raised to the fourth power. By applying the power rule, we bring the exponent 4 in front of the logarithm. This equals 4 times log base 10 of 10. Since the logarithm of 10 with base 10 is 1, we can simplify this further. Therefore, it becomes 4 times 1 equaling 4. This simple example shows how the power rule can make complex calculations much more manageable. The power rule makes working with exponents a whole lot easier. By understanding and applying this rule, you can tackle a wide range of mathematical problems with confidence. So next time you encounter an exponent within a logarithm, remember the power rule and bring that exponent down to earth.